All right. Hello.
Hey, everybody. Luke, good to see you.
Thanks, Luke, for coming on. This is our fourth office hours. So really looking forward to kind of getting in deep and talking all about computer engineering. And there's a lot of things that we get to talk about today. But yeah, Daniel, if you could just introduce the series a little bit here.
Yeah, absolutely. So we have Luke Buckland with us today. Do you go by co-founder? Do you go by CEO? Do you go by co-founder and
Uh,
CEO?
yeah, co-founder probably most appropriate. Yeah.
All right, co-founder of a autonomous robotics AgTech company. So Luke's interesting as a engineering case study, deep engineering experience in computer engineering, teleoperation, autonomous vehicles, driverless cars, right? So heavy background in all these areas, which we're going to chat about with him. But recently took a fascination to the modern day farming industrial complex, right? And realizing the inefficiencies there and what could be done with some of what's happening with Uber and driverless cars. If you take some of that technology and apply it to farming, what a meaningful impact it can have. So, we're going to learn today about not just self-driving cars and teleoperation, which I hope we do, but also about modern day farming practices. Luke's been traveling to a bunch of farms as they've been rolling out these new product lines. And then we're going to combine the two and talk about farms and autonomous vehicles and robotics, what it looks like when you bring it all together and what the next future couple of years of farming could look like. So will be a lot to pack in, but I'm looking forward to the conversation. And for anyone who's tuning in on YouTube or Facebook or LinkedIn, we're live to all those channels. At any point, you can drop questions in the chat, and and Luke will answer those as well. So welcome to Live Office Hours, and let's get going.
Yes, thank you, Daniel. And like Daniel mentioned, drop any questions in the chat, and we'll be able to see them. And then you can also direct message me if you'd like to come on board and ask a question directly to Luke.
Don't direct message me. I don't know how to let you on.
So we'll go ahead and set it up like this now. And Luke, we'll put you right here. And so I'll go ahead and try to go through your background, and please feel free to correct me if I get anything wrong. But like me, actually, you went to UC Santa Barbara and studied, have a bachelor's degree and a master's degree, correct? Bachelor's computer engineering and master's in electrical engineering.
That's it. Yeah. Yep.
Cool.
Yeah.
Yeah, fellow gaucho. So stoked.
Go Gauchos.
Yeah, and when that was graduated about 8 years ago.
Yeah, thereabouts. Yeah. Yeah.
Okay.
Yeah.
And then from there in Santa Barbara, there was a company, Tracker, and Tracker was a consumer electronics product that kind of blew up. They grew super fast. Bluetooth trackers for asset tracking, right?
That's right. Yeah. Yeah.
And so working as the lead firmware engineer there, and then from there, kind of like change directions into autonomous vehicles at Polysync.
That's it. Yeah.
Awesome. Well, and
with Polysync, were you still in Santa Barbara, Luke?
No, that was up in Portland, Oregon. So yeah, towards the end of my master's, I was doing research in drones at UC Santa Barbara, and then I did a kind of a stint with Tracker, but then I got pulled up north to Polysync.
And with Tracker, you were super low level in the embedded C code, right? You were doing firmware. Were you still doing firmware with autonomous vehicles, or were you working to more a software and cloud level?
Yeah, that's a good question. I did a lot of different stuff for Polysync. I did get pretty low level. We developed a product called open source car control, which basically allows you to hack into Kia Soul, various types of Kia Soul. So Kia Soul EV, the Kia Soul gas powered, and the hybrid. And you can basically install hardware in the vehicle, and it allows you to spoof commands to it. So you can basically drive those vehicles with a computer. So that's how you kind of do testing, do autonomous testing. And
hold on, help me visualize this. So there's a Kia Soul, And you drill into the dashboard and plug in your Raspberry Pi and take it over? Like what actually happens here?
Yeah, that's a good question. It was a lot of fun. I mean, that was probably my favorite part of the job was kind of digging into these cars. A lot of people don't know. I mean, cars are not very. I don't know if private is the right word, but if you know what you're doing and you can kind of connect to the buses on a car, usually it's a CAN bus, then you can kind of see everything that's going on and sniff the CAN bus and reverse engineer it. And so we would kind of start with that. So we would get up under the dash where your OBD port is, and for people that don't know, it's usually below the steering wheel, and we kind of connect in to that and sniff the CAN commands or the CAN messages on the bus, and we kind of understand how the car was operating and how these messages were kind of controlling the car. And then from there we would kind of figure out, okay, how can we insert our own messages to control the car? And sometimes it involved spoofing CAN messages on those buses, or sometimes it involved intercepting signal wires. So we would kind of snip is not really the right term. That's how we would test, but eventually we had custom connectors. So we would kind of insert our embedded board between the car system and the steering wheel, and then we would send our own steering commands in place of the power steering control, basically. And we would do the same for braking.
The power steering can actually completely steer the car?
It can actually, yeah, it can. Yeah.
In like most modern cars, or like.
Yep.
Wow.
And would that win relative to if there was a driver sitting there on the wheel turning the wheel? your hack sniffer would take over priority?
Well, that's a good question. I mean, we had to put a lot of safety stuff in because obviously it's dangerous to be fighting someone who actually maybe needs to grab the wheel for safety reasons. But yeah, I mean the steering model will you can fight it because I had I did that with early testing just to see how strong it was, but it's got a lot of torque in there, so yeah.
That's scary. I mean, it's cool, but also scary. My mind goes to nefarious places for sure.
Yeah. Well, the good thing is all cars, they have to have double redundancy and everything. So your steering controller has 2 signal wires, your brakes the same, so everything has a backup in modern vehicles. So if one goes out, then the other one takes over.
And so we got sidetracked at PolySync. So back to you, Danny.
Yeah. So I mean, but you had a number of different companies in the space, right? And you also did start a company in the space called Designated Driver.
That's right. Yeah.
Yeah. Can you just talk a little bit about kind of your transition across the autonomous vehicle space?
Yeah, for sure. Yeah. So yeah, started at PolySync. Did kind of a lot of kind of robotics-y things at PolySync. At that time, the autonomous vehicle industry was fairly new, and there was a lot of kind of early stage startups, and they're all kind of had an angle. Nowadays the autonomous vehicle industry has kind of conglomerated, I guess, because it takes a lot of money and time to build an autonomous vehicle. And so if you don't have the backing of, a GM, say, then, your little startup's not going to be able to build a full autonomous stack. You can build a piece of it. And that's kind of where we were going with Designated Driver, or where Designated Driver is going now. So teleoperation is a way basically to take autonomous software, which maybe is functional 95% of the time, or even functional a little bit more frequent than that, or fails less often than 5%, and give it that little boost to bring it to production. So you're always going to have, no matter how good your autonomous vehicle is, you're always going to have a certain percentage of the time that it just doesn't know what to do, because driving is hard, and there's a lot of corner cases, and you just can't. We'll get there eventually, but it's going to take a lot of time to eliminate every single corner case. So teleoperation allows you to basically give insight to autonomous vehicle or help the autonomous vehicle out if it gets stuck or runs into trouble. And that can look like direct control. So, you're directly controlling the vehicle, or you're doing kind of indirect control where you're sending the car, helpful commands to kind of assist it, but you're not really taking over it completely.
Awesome. Thanks for some clarity there. And so designated driver is moving forward, and that's in operations in Portland.
Yes. Yeah.
With operations in Portland. Okay, cool. And then talk about a little bit about the transition to the AgTech space. I know that what you're building in the AgTech space is, still, it's not public yet, but it's an exciting industry. In fact, we actually had we have a partnership with a company called Hardware Massive, where we sponsor events, and one of yesterday's event was actually in the agriculture AgTech space. So we got to hear about indoor farming and packaging problems and international kind of shipping of food and flowers, and it's just it's a fascinating space.
There's a lot there.
Yeah.
Yeah. So kind of the impetus for this, switching over to AgTech or ag robotics is, and I touched on this a little bit, earlier when I was talking about the kind of progression of the autonomous vehicle industry. The autonomous vehicle industry, and there's some other industries that have built up quite a lot of technology to address a quite complex problem. So, in the case of autonomous vehicles, there's all these advanced sensors and algorithms and, the whole stack, and all of this has been developed to drive a car on the road, which is really, really, really hard to do. And so, but you can take that technology, the algorithms and the sensors and all the stuff that's been developed, and kind of apply it in other industries where the problem is still difficult, but maybe just not as difficult as on-road driving, where there's so many corner cases. And whenever you can apply robotics in a way where you can kind of have somewhat of a constrained environment. So there's no guardrails in on a farm, but you kind of get the idea. You can kind of adapt your environment a little bit to suit the robots, and to help them out. So if you kind of take that concept, you can take this technology that does quite well with autonomous vehicles and apply it in things like AgTech, and make progress faster and come to a solution that can help people out faster.
Awesome. It makes a ton of sense. And robotics is fascinating as well. Did you have any stint in robotics prior? Or was it all from the autonomous vehicle industry?
Yeah, so I actually started in drones. In college, I was working on a really...
Okay, so wait, consumer electronics, drones, and robotics.
Yeah. Yeah. It's done a lot of different stuff. Yeah.
But yeah, please, sorry.
No, you're good. Yeah. So we were working on a project when I was working on my master's. My advisor was in charge of a project where we were using Wi-Fi to map interior spaces. So you can use signal attenuation to map a room, basically. See if there's people in the room, see if they're kind of moving around the room. And this is interesting because Wi-Fi is everywhere, right? So if you can kind of leverage existing technology and use it to find survivors in a disaster situation, then that's pretty cool and pretty useful. So
I'm confused, but signal attenuation. So like a Wi-Fi source.
Yes.
And then you can actually map a room visually from broadcasting devices.
That's it. Exactly. Yeah. So what you can do is, if you have a router that's putting out a signal, and you have a receiver, if you move that receiver around a room, or you have multiple receivers, then you can, use the algorithms that lab was building to map the room and kind of determine how many people were in that room. And even I think they've gone even further and even kind of are tracking people as they move around in the room. So
yeah, historically you could only do that type of analysis through triangulation. You had to have at least two, right? You could look at the comparative attenuation across the receivers, but I forget which protocol it was that allowed for some amount of directionality from a single receiver, and then you could start mapping from a single point. And so that sounds like probably what you were doing, right?
That's right. Yeah. Well, it was triangulation in a sense that the receiver was being moved, around the room, and that was my I was building drones that could basically carry the receiver and take those measurements. So
I see. So you're triangulating over time with the single receiver.
Yeah. Exactly. Yeah.
Very cool.
One thing I'm curious about before we get into the farm segment of the chat today, obviously Danny and I are from Ioterra. We're very interested in all things IoT, and like a autonomous vehicle is a very, very complex IoT device. But then there's also the very, very simple point low compute nodes, right, that are broadcasting themselves. As self-driving cars evolve, something that I've been wondering a lot about is, are the streets going to become smart? Are the signs going to become smart? The traffic lights? Are they all going to be talking to each other? Or is it simply recreate a human brain in the car and then leave the environment as it is today?
Yeah, it's a great question. And yeah, there's a lot to talk about there. I think, I guess my personal opinion is that kind of there is going to be some talking. Let me start with this. I guess at this point, the technology is more focused on kind of advancing the vehicles, just because there's so much data that you have enough to work with what you have on the vehicle, and you have to get it to a certain point to be able to kind of bear the fruits of being able to communicate with other things. That being said, there are some helpful things like I think you mentioned, street lights. So instead of having to have a camera that can detect whether the light is green or red, you talk to a radio that says, hey, the light is green or red, and that can be very helpful. Because then you can not worry about that whole sensor that's kind of looking up at the clouds looking for for lights.
Yeah. Yeah, it's one of those things where I guess I would want redundancy. Like if I'm the passenger, I want to do both.
Totally. That's the thing. And I guess what I would say on this, if you think about existing infrastructure, I think it's really cool, and I think I would love to see more kind of IoT devices installed in the roads and being used by autonomous vehicles. One thing that's really cool maybe is having like a high-speed highway where you only have autonomous vehicles and they're able to go at like 200 miles an hour, and kind of just blast down the highway. In general, if you think about city infrastructure, and kind of the quality of the roads, even just with the pavement and stuff, it's not well maintained. And so when you add new technology and new sensors, it gets more complicated. And so that it gets to your point, can you rely on the sensor to be properly maintained, as you kind of add more technologically complicated things to a, I don't know, autonomous environment. So I think it works well in a constrained area where you're specifically serving autonomous vehicles. I'm a little skeptical whether it'll be more widely adopted just because of the overhead of maintaining the sensors. But I think like I forget the exact term, but when having two cars talk to each other is quite interesting, and another kind of flavor of that, because you can kind of do some fun things like share information, right? Some car can see maybe further down the road, and so tells the other car behind it that there's an obstruction coming up or something. So yeah, to me that seems maybe where things are going, but I could be wrong as well. So
It's fascinating.
Yeah.
And it's one of those things where like I imagined we'd be in flying cars by now, like 5 or 6 years ago. But
Well, I hope
everything
so.
moves slower than I always think.
Yeah. Yeah, I'd love to fly over the traffic one day. That would be fantastic.
Yeah. And also, before I forget, I wanted to mention that, and I'll put this up here, but we're going to have a community forum where there'll be a forum channel that's specifically dedicated to Luke here in this conversation. So if you want to reach out to Luke, you can reach out through this channel, or ask questions, as well as just connect with you directly on LinkedIn. So putting that in there for people who want to connect. And I think that we also missed the quick pitch on Ioterra. So just to talk a little bit about us, we're trying to promote everything IoT product development and just open up discussions around product development. There's a lot going on in the space and a lot of people building cool things. And so we're trying to connect people. So that's us. And yeah, I'll drop it back over to you, Daniel, and maybe we can start talking a little bit more about robotics in the AgTech space or just the AgTech space in general.
Yeah. Well, let's talk about your learnings, Luke. When you and your brother, we've left him out of the story so far, decided that you wanted to bring some of your engineering background to the farm space. I'd be curious about your approach to really get exposed into what the agricultural industry looks like today, and then what you learned over the past several months of maybe where there's areas for innovation.
Yeah. That's a good question. I mean,
we actually know another brother co-founding Pay, and they go by the title of a bro founder. So you can think about that too, and potentially make that your new title instead of co-founder.
There we go. Yeah, bro founder. That's it. Yeah. That's cool. My brother and I started Bovi, which is the name of our company. And Connor comes from a background, quite varied background, different types of robotics, industrial robotics, food robotics, and construction robotics. And similar to me and kind of my experiences in autonomous vehicles, there's a lot of technology there that is being applied to solve really hard problems that maybe could be used to solve, also hard problems, but get to market faster. Anyway, so how do we kind of dig into the space? We kind of reached out through our network, and we're lucky that a few friends of ours knew farmers who were kind of doing stuff in the areas that we were interested in. To start, it was really helpful in getting kind of sense of the industry because we hadn't really worked in AgTech before. Attending a couple conferences, talking to other founders, CEOs in the space, and kind of about their experiences. But really, kind of just hitting boots on the ground and talking to farmers, face to face when possible, or calling them, and saying, hey, could I take 5-10 minutes of your time just to ask you a few questions? That's been extremely fruitful, and we really found the community is just so welcoming and really open to sharing information, and we've really found some great interest there, and been able to kind of glean some insights about what's interesting to them to improve efficiency and all that. So yeah.
And because I've always assumed or just heard that how welcome are they to adopt new changes? So it sounds like they're welcome to talk, but it's not like typically a space known for technological integration.
Sure. Yeah, that's a good point. I think it has to be, you have to be solving a problem. And that's true in any industry, right? But what I've heard, and this is what I've heard kind of secondhand, is that there's been a lot of attempts to create technology and then say, hey, we got this cool thing that does this, and that's fantastic. But farmers have been doing things a certain way a long time, and it works really well. And so why would they take a risk with something that could affect output if it's not a proven solution? And margins are also thin in a lot of crops, so it's tough to justify taking a risk when they know that their method works. So I think the key is, like any industry, really asking people, hey, what are the real problems? What do you need solved, and how can I help? And approach it in that way, and really understand the industry, and then build something. So.
Awesome. And I know that
Danny, I would push back too on the comment that the industry is not known for technological innovation. If you've ever driven through Idaho, you see all of these industrial agricultural, robots, right? They're various types of tractors, but I feel like I'm on the Galapagos looking at Darwin's finches when I drive past these things, right? Because they're in all these different shapes and sizes, and there's different size blades and different looking shovels. And it's, obviously they were all purpose built for something, but I'm not in the space and I don't know what that something is. And I just see this gala of strangely shaped, gigantic tractors.
Yeah,
and I think really only potentially second to mining, which has absolutely massive equipment. Farming has some of the most massive machinery and robotics that are out there, right? So it's a different type of technological innovation than what's coming out of the crypto, blockchain, AI, Silicon Valley. But it's innovation nonetheless, and it's interesting to see bridges starting to be built.
Yeah, on that point, I have to say, when you start talking to farmers, they're extremely technical, and you hear stories like John Deere was kind of not allowing farmers to repair parts of their tractors, and farmers were going in and like hacking their own tractors and fixing the problem themselves. So talk to certain guys who just they'll have a problem in their farm and they'll just build something to fix it. Custom hardware or custom machine, and so there's to your point, Daniel, there's a ton of innovation going on, and yeah.
It kind of reminds me of the Love, Death, Robots episode, Suits. It's so awesome. Yeah. The other thing, to back up your point too, Daniel, the last CES that I was at, I guess the last one they had like before pandemic stuff was I got to see the John Deere booth and it was a gigantic, weirdly shaped tractor robot that you could walk into. So yeah, there's a lot going on for sure. And I know that, Bobby, you guys are, coming out with your first solution, so you can't talk too much about it, but can you go into some of the challenges of building robotics in general? Because, there's the physical elements as well as the, firmware elements, the programmatic elements. Like maybe if you could, just talk a little bit about that.
Yeah, for sure. Yeah, I think it comes down to building robust robotics. You can build a robot that does a thing, really cool thing, but can it do that really cool thing 100 times, 200 times, 1,000 times, especially in an agriculture environment where there's a lot of salt in the air, a lot of corrosion, lots of water, very dirty, bugs. Yeah, all the above. It's hot, here in California, it gets extremely hot. And so, I think that's really the challenge in robotics, and to point to autonomous vehicles again. We've seen the industry, 10 years ago, they're like, oh, autonomous vehicles, 5 years, right? And then it's been another 5 years. And that's because it's really hard, and you can get to autonomous vehicle that operates 80% of the time, but can you get an autonomous vehicle that operates 98% of the time, 99% of the time? That last, few percentage points is where all the effort is, and it's hard to estimate, in the early stages, how much effort that will be, because it's a new technology. So I think that's the big challenge, is redundancy, safety, all those things. Yeah.
I do know I was in San Francisco this last weekend, visiting some family, and I saw that Waymo car literally like probably 17 or 18 times just doing loops.
Oh
I
yeah.
actually saw another brand too, but there's a lot of action there right now.
Oh yeah. And you just need petabytes of data. I mean, just, that's what they're doing. They're collecting new data every single day and running simulations at the same time. It's just, to get things that work reliably, it's just amazing the amount of effort that needs to go into it. So, yeah.
Awesome. Well, yeah. So are you specifically, like, your role right now, you're more on the programming side? Are you guys, can you talk a little bit about kind of what you're specifically involved in terms of like the work that you do?
Yeah, the day-to-day. Yeah.
Yeah.
It's myself and my co-founder, we're both kind of wearing a lot of hats. Connor and I are just taking on everything as you do kind of in an earlier startup. So, it's a mix of working with hardware, working with software, and then a lot of kind of continuing to talk to farmers and understand the problem there, and make sure we're kind of building something that addresses those problems. Because it's like kind of touched on before, a lot of crops are narrow margins, and it's hard to justify taking a risk if it's not something proven that'll work. And again, this is something I've heard secondhand as well, but it gets back a little bit to reliability in robotics. I mean, so if you bring a robot out and you say, hey, this thing can do this cool thing, and you show it and demo it, then the farmer will ask you, okay, that's great, but is it going to be working in a year from now, right? Which is a quite valid question. Given the amount of money that you kind of have to invest in technology like this. So yeah, to answer your question, lots of different things, trying to talk to customers as much as possible, or potential customers, and then, digging deep into the hardware and software, getting hands dirty and all that. So.
I'm curious about what types of technology you've seen already deployed in the farms. Yeah. In the past, Danny and I have been involved in building sensors that can go into farms, alfalfa farms, among others, that keep track of the temperature and the dew point, the amount of precipitation, wind speed, that kind of stuff. But the problem has always been farms are a rough environment. I mean, you were just describing that. If you put a sensor out there in the field and it's small, it's going to get driven over by a tractor, right? You can hang it off the bush, but then, other stuff can happen to it. The birds can peck at it. So yeah, I'm curious what you've seen that's recent technology innovation deployed in farms, and maybe some of the things that they're doing well, and some of the ground that we still have to cover.
And do tractors have power steering?
They do. Yeah. And yeah, that's a good place to start. Maybe there are a couple companies, a few companies actually, that are working on, doing something similar, hacking existing tractors, right, and controlling them. I won't speak to whether we're doing that as well or not, but but it exists. It's a model, and actually, one of those companies just got acquired by John Deere in the last couple of months. So that was kind of a big deal. They were developing basically sensor suite and software and hardware that you could retrofit to a John Deere tractor, and then allow that tractor to kind of drive and tilling. They were doing tilling, so tilling fields autonomously. And you could just kind of let it go, and it would till the whole field and then stop. So that's kind of one big initiative. There's another initiative, building new robotics to kind of augment existing vehicles. So doing a whole swath of things, data collection, carrying heavy loads. What else? Yeah, just a bunch of stuff. There was one company that, unfortunately, I think kind of tough time in the pandemic. They recently closed up shop, but they were working on apple picking, which is quite a complex problem. A lot of moving parts to that, and they were taking on, and is quite cool to see them do that. So yeah, and then I guess maybe the viewers are more interested in IoT stuff in the farm as well, and I think there's a lot of stuff there. Seeing stuff like sensing different things around the orchard. So water levels, stuff like monitoring your crops to see if it's has healthy mineral levels. Stuff like that is pretty cool. And then there's a ton of stuff I could keep going on, but I'll touch on one more here. One thing that's really cool is using satellite imagery to map orchards or other fields. And basically they can take a snapshot, very high resolution, and process that image and tell, which parts of the field are doing well, which parts of the field are maybe doing less well, and then kind of in real time, adjust the water or the pesticides or what have you to kind of address different issues that might be coming up. So
Awesome.
That's really cool because it's very scalable. Yeah.
That actually, that was one of the things that we heard about yesterday in the AgTech panel.
Cool.
And a couple of questions in the chat here. One from Christina. Luke, what's the most challenging part about your new venture in agriculture? Where are the big pains, and are they more technical or commercial?
Yeah. It's a good question. We're still, I'm sure there's many more kind of pains we'll experience as we kind of grow the company. The early, kind of breaking in the industry was definitely somewhat tough, and I wouldn't say that we're there, but we've gotten a lot of great feedback, and talking to a lot of great people, and have some good connections there now. So I think that's one challenge, is kind of getting that feedback and kind of earning some level of trust, and then and collecting that, and then the big pains. I think there's a big challenge in how do you. I would say that the agriculture right now for this technology, there's differing opinions on this, but from what I've observed, we're kind of early in the process of bringing robotics to agriculture, and so in some other industries, there's existing infrastructure to kind of facilitate the adoption of this technology, whereas in agriculture, you kind of have to do everything yourself, which has its advantages. I love kind of taking on a tough problem and finding all the different facets of it, but you makes it also tough, and so you really have to work with other companies to create effective solutions, and then
I'm imagining, the robotics that I've seen have been in the machine making space, right? I've seen machines, robotic arms, like loading CNC mills and lathes, but it's all in an environment that's very well controlled. So I'd imagine that would definitely be tough.
That's a good point too.
Another question from Katie with regards to the the chat yesterday in AgTech, there was a question on vertical farming. Has robotics in general become more involved with that method? To your knowledge?
Yeah, that's actually something that's quite interesting that I didn't touch on as part of the kind of evolution of robotics in AgTech. But yeah, there's quite a bit there. There's a lot of interest because you can, the theory is that you can kind of put smaller scale growing operations for food in cities. So you can have like a supermarket with a little vertical farm behind it for fresh greens and stuff. It's a cool concept, right? And there's other advantages. I'm not as familiar with kind of that side of things, but there's the kind of constrained environment makes it again conducive to robotics. So I talked to a guy who was working with planting cabbage and growing cabbage with hydroponics, and you can build a robot that just does everything. I mean, it like drops the mesh in there with they use like a neoprene mesh with a seed in it, so they put that in the water, and then it grows, and then when it's done, the robot comes and picks it up. So you can kind of pretty much automate. We have the technology now to pretty much completely automate vertical farming, and that's pretty cool. So yeah.
Yeah, no, I mean that's kind of one answer to the question we were just talking about, like how do you bring infrastructure, put it inside.
Yeah. Well, yeah, constrain your environment, right? I mean, if you don't have the sensors to operate freely in an unconstrained environment, then you can constrain your environment or add cues or whatnot, which you can do outside. It's just not as easy as indoors. So yeah.
So Luke, I imagine that machine vision is a big part of what you do and what you've worked on in the past. Is that right?
Yes.
Can you talk about some of the tools that you like best for doing machine vision type work?
Yeah, actually, I should have brought Connor on as well, because this is a little bit more his foray. Let's see. There's TensorFlow. It's a pretty common tool that's used. But in general, you can kind of hit the ground running. There's a lot of open source models that we can bring in that have identified a lot of different things. I mean, I think one of the bigger models has, I don't know, like 100 different objects that it can detect, including people, bicycles, all this stuff, right? So you can pull it in and you can kind of work off of it. And you have to adapt things because it's not perfect, but you can at least kind of say, hey, look, it detects this thing, and then work off of it. So I would say machine learning in general, especially for vision, there's a lot of kind of building blocks that you can use nowadays to get the gun running. You don't have to like train things from scratch, which is pretty big. So
yeah, I'm sure that's a relief.
Yeah.
So with regards to like cameras, basically using cameras to detect things, I imagine that's huge right now.
Yeah. Well, that's a good question. Cameras are cheap, right? And the more cost-effective a robot you can build, the better off you are. So it's a good approach. A lot of people say humans just use cameras, so why can't robots also just use cameras, right? And it's a valid point. LiDAR and LiDAR is like a laser scanner for people that don't know, is another prevalent sensor. If you do some kind of smart stuff, you can see through dust and other particulates in the air, which is pretty cool. And then you can get basically a three-dimensional map of your environment. And that has its advantages as well. Radar is kind of more can see through dust, but is a little maybe like lower resolution than a camera or LiDAR. You can see objects
those large wavelengths holding us back in radar.
Yeah, exactly. Yeah.
All right, on the training of the computer vision algorithm. So this is something I've always wondered. It's always bugged me a little bit. Like one of the things that we train robots to be really good at is identify a bike in a picture, for example. However, when I'm on the internet and I'm being asked to prove that I'm not a robot, it gives me the 6 images and I have to select where the bikes are. And I just feel like that's something robots are actually good at. And it turns out I'm not. I always fail those things. The internet always thinks I'm a robot. So you know, since you live in this space, do you have any insight on why those are being asked as the questions?
Well, that's actually interesting. I kind of have a personal theory that actually Google, who's behind those CAPTCHAs, is using those to help train its vision algorithms a little bit better. It's kind of using humans to help out. So you guys are all maybe helping train an algorithm a little bit better. I have nothing to support this, but this is my personal.
I mean, that's always what I've
Sounds
wondered too.
right.
Because it's just a weird test to
it's
prove
weird.
that I'm not a robot when that's when they do. But yeah, it feels like I'm being real life Turing test every time.
Exactly. Yeah.
And Aaron's heckling you in the comments.
That's usual.
Okay, another one. Thanks, by the way, Christina and Kitty and Aaron for tuning in. And from Christina, this might be a hard one, so feel free to skip it. But what are your thoughts on farmers losing their jobs as they get replaced with robots and automation? To what extent is this happening?
Yeah, that's a great question. Yeah, we get asked that. We get that asked a lot, and it's a valid concern. What I would say is, farmers are not so much at risk of losing their jobs. Well, let me take a step back for a moment here, because it's quite a complex problem, and it's interesting because of kind of the costs of running a farm, and a rise in labor costs. A lot of farmers that used to be kind of family-owned farms, passed down 6-7 generations, are now kind of unable to run their farms anymore, or not interested. So there's kind of a move from kind of family-owned farms to larger commercial farms that can kind of take on the cost and the risk of this. And the bigger farm you have, the more robust you are to fluctuations in price, and you can kind of get that narrow margin and still make it worthwhile. So unfortunately, there is kind of a trend. It has nothing to do with robotics, to family-owned farms kind of being owned by larger commercial entities, and that's actually something that we would like to help out with, because if we can reduce the costs of running a farm, then we hope that we can help some of these family farms stay around. So that would be great. The other side of it is, so if you're kind of building robotics to make farmers more efficient, then they need to hire less, in the field workers. And so, how are their jobs affected? And it's definitely a concern. But there's also a trend there. I mean, if you go out in the fields, and see the work that's being done, it's really hard work. It's hot. It's backbreaking. I mean, these guys and gals are out there, and it's tough. I mean, we've kind of tried it out for a day, and it's like, I don't know how they do this day in and day out. It's just really, really tough work. So there's kind of a move. A lot of workers who used to be in farming are actually going to other industries, construction and whatnot, and they're get paid similar wages, and so there's just kind of a natural move to other industries for in-field workers, and when you so actually farmers have a tough time finding labor, even when kind of increasing wages. But what I guess my last point I'll make is that if you bring in robotics, then you're still paying the same people to do the same job, but they're more efficient, so they bring down a kind of higher wage. Yeah, and it's less backbreaking. I mean, it's like I said, it's just like really tough work. So
yeah. Awesome. Well, yeah, thanks. Thank you, Luke. Daniel, do you have any more questions? Because what we could do is, again, I'd like to put up the banner. Please reach out to Luke on LinkedIn. Check out bovie.ag for updates. And then community, we'll discuss, and all the questions that were asked will be on this community forum, and other people can ask more questions if you missed the live event.
Yeah, I have a final question or near final. Luke, as we keep tabs on bovie.ag over the next 6 months, what should we expect to see from you guys?
Well, we'll be releasing a prototype, which maybe I can. Sorry, guys, just turn my phone off here. Yeah, so we'll have something to share, which should be pretty cool. So I have to share it with you guys again. Yeah.
All right, sweet. So sometime in the near future, there's going to be a cool surprise, something that's going to make some waves in robotics and ag tech. So, all right, I'm looking forward to keeping up with that.
Awesome.
All right. Well, thank you, everybody. And we'll go ahead and close out here. And thank you again, Luke, for jumping on. This was super fun conversation. I had a blast.
Big thanks, Luke.
Yeah.
Thank you, guys. Yeah, I appreciate it. Yeah.
All right. Have a good one.
All right. Have a good one.